Go. All right, so today we're going to cover analyzing categorical data. This week we're actually going to have two streams going, me and Jerry. Jerry will be doing the sampling data, sampling methods and biases. Yep, so that's where we are. Sorry. Please go ahead and follow Think Fiveable on all the social media platforms, Twitter, Instagram, YouTube. That's where you can find updates on when we're going live and all the other important things that are going on with Fiveable. Here's what we're going to be doing today. We're going to have our intro, learn the vocabulary of data, construct and interpret categorical displays, and interpret two-way tables. At the end, if we have time, we'll do a deep dive into a Kahoot to see or to get some practice. Sorry, I'm just adjusting my screen so I can see the chat. All right, moving right along. So here's kind of an overview of statistics. It was my favorite class in high school. It is my favorite class to teach. And this diagram kind of shows why. So statistics in general, what we want to do is we want to know something about a population. So there's a population that we're interested in. It could be something like the students at your high school. It could be something as large as the voters in the United States. But because it's so tough to get information from a population, what we do instead is we take a sample and we collect data from that sample. Ideally, that sample is a representative sample. And what I mean by representative sample is it has to represent the overall population as a sample. So that small sample needs to represent the larger population. The reason for that is if we don't have a representative sample, then the number that we collect from that sample is going to be what's called bias, and it's not going to help us with the overall population. So we take a small sample, we collect data from them, we then perform data analytics, keeping in mind probability. So we do some sort of inference, whether it is a hypothesis test or a confidence interval. We do some sort of data analytics, and then we use that to make an inference about the population. So you see this every single day. You see it a lot in politics, where they say Hillary Clinton or Donald Trump has 45% of the vote. Well, they don't know that for a fact. They took a sample. Based off that sample, they ran some numbers, and they used that to make an inference. So statistics is used in pretty much every field, especially moving forward in this whole data mining generation that we're getting into. So we're seeing a lot of data scientists pop up. Statistics is kind of the foundation of that. So in statistics, we have what's called a variable. And a variable is any characteristic of an individual or an object. So it's any trait that some individual, like a person, or some object, like a car, has. So to give you an example, variable could be who you're going to vote for in the next election. So the characteristic is who you're voting for, and you are the individual. So a variable is anything that we want to measure about an individual or an object. We have two types of variables that we're focusing in this year. So the first is categorical. Categorical variables, usually an adjective and rarely a number. So if I ask what car you drive, that is a categorical variable. If I ask what's your hair color, that is a categorical variable. So it's something that when you tell me a number, or sorry, when you tell me your answer, it falls into a certain category. Now it says rarely a number because sometimes a number identifies a category, and we'll talk about that on the next slide. So we have categorical variables. Then we also have what's called quantitative variables. Quantitative variables always is a number, and you must be able to find the mean of that number, and it should make sense. So the age of a student at your high school, that is a quantitative variable. It's a number, and I can take the average of a bunch of those numbers. The average height of a US American, that is a quantitative variable. So a variable is any characteristic that we want to measure, and we have two types of variables. Diving into a little bit more about what the difference between categorical and quantitative is. So we have race. That's going to be categorical. If I ask what is your race, you'll give me a category, and it's something we can't average. So I can't average all the races of my high school. Right? It just doesn't make sense. Another type of categorical data, and this is where we said rarely a number in our last slide. So yeah, we said categorical variables is rarely a number, because in this next example down here, zip code, that is a categorical variable, and it is a number. So it doesn't make sense to average all the zip codes, but it is a number. So the number indicates the area or the region in which you live or in which you are. So although it is a number, it is still a categorical variable. On the other side, we have what's called quantitative. Again, quantitative is a number, and it makes sense for you to average it. So GPA is a quantitative variable. And below that, you'll see some examples: 2.0, 3.14, 1.8. Right? We could average those and get the average GPA of whatever population we're looking at or whatever sample we're looking at. So we're going to go back and forth between population and sample. Remember, population is the entire group. Sample is a small subset from that group that is representative of the group. So GPA is a great quantitative variable. Also, the number of AP classes taken. That's quantitative. We could average that number. You could be taking 0, 1, or if you're super ambitious, you could be taking 5. I see a couple people popped in. Go ahead and let me know if this is review, if this is brand new to you. That'll help me kind of tailor this as well. Okay, so we have our variables. In statistics, it's really, really important to display your data, to display the variable that you're looking at. So a distribution describes what values a variable takes and how often it takes those values. Distribution essentially replaces the word data or graph. So we love distributions in statistics because it tells us and it shows us the data in a more manageable way. So below, you see a dot plot, which is one way to show quantitative variables of MPGs. So MPG stands for miles per gallon. So it's cars and how many miles they get per gallon. So we're going to notice one car gets 14 miles per gallon, and we can kind of see that right there. One car gets 18 miles per gallon. So the variable that we're measuring is miles per gallon, and this data display or this distribution shows how often those values take place. So it looks like the most often there's 3, 25, 28, 29, and 33. It also shows us the spread of a distribution, which I'll go live later, either this week or next week. I got to work it out in my schedule to show how we describe a distribution. So a distribution essentially replaces the word data or graph, and it describes a variable and how often it takes place. Here's a great distribution of categorical variables. We can do two things with categorical variables. We can list the counts, so the actual physical number of people that chose that category, or we can show the percentages, so what percentage of people chose that category. So here is a survey asking students, what was your favorite course this past year? So the different categories were English, foreign language, history, math, and science. In each category, we can measure the counts. So the number of people that chose English as their favorite course was 8. The number of people that chose foreign language, 4, and so on. So that's one way we can display it. we can also display it as a percentage. And that kind of allows us to compare a little bit easier. So if you look at the percentage of English, that was 16. Now, where are we getting that percentage? Well, we would total these, which I believe it totals to 50. Divide whatever count you have, whatever count you're looking for. So if I'm looking for English, I would take 8 divided by 50, and that would give me my percent. There are two main ways we display categorical data. That's a bar chart and a pie chart, or a bar graph and a pie chart. So if you look here at our bar graph, we have count of stations. So this we're working with the count, which we saw in our last one, right? The count right here. So physically, how many stations are playing each of these categories? Remember, this is categorical data. So we can easily see which one has the most. It looks like news and talk. And we can see which one has the least, contemporary hit. We like bar charts or bar graphs because it allows us to see and compare with our eyes rather than spending a lot of time looking at the numbers. This is a count, right? This is a physical number of stations. We also can show the percent of stations. So the percent of stations, we're using a pie chart. Now, pie chart, the whole thing adds up to 100%, and then we make slices out of that based off the percentage. So it's the same data set as this one right here. However, I've broken up into percentage. So we said news talk was the biggest number of stations. Over here in our graph as a pie chart, we should see news talk as the largest chunk as well. And if you look here, it is 16%. So it takes the largest chunk of the pie chart. Next would be country, and then we can see the rest as follows. So bar graphs and pie charts are the way we display categorical data. There are good and bad ways to display categorical data. Our eyes react to the area of the bar as well as the height. So we really want to make sure that our bars are equally wide. And this is a good example of that. So let me go back one more. We want to make sure that our bars in our bar graph are the same width, right? So I don't want one to be bigger than the other, because if you do that, here's what ends up happening. It looks misleading. So this part right here looks like DirecTV is like way better than Dish Network or cable. But in reality, they only have about 14 more channels. But it looks like they have a lot more because see those bars, the bottom? See the width? DirecTV is much larger than Dish Network, which gives the illusion that they have way more, maybe double or triple the amount of Dish Network. So this was an ad that they ran, and very misleading. So you want to make sure that you keep your widths the same length and make sure that you avoid replacing bars with pictures, because the second you put pictures in there, it can kind of distort the actual numbers. All right, another huge part of categorical data is called a two-way table. A two-way table describes two categorical variables organizing counts according to a row and a column variable. So we have two different types of variables. One is in a row and one is in a column. We begin by examining the counts or the percentage in various categories for one of the variables. So we really start by analyzing one of the variables. Remember, we have two. So we start by analyzing one, and then we do the other, and then we can do both at the same time. So two-way tables are a great way to see relationships among two categorical data sets. And we'll do some practice problems in a minute to show how we actually get those values. Okay, so here's a good example. We have two categorical variables here. One is organized by column, one is organized by row. First, let's talk about the row. So the row is the categorical variable. How do you get to school in the morning? You either ride the bus or you don't. So our row, our one variable, is how do you get to school? You either ride the bus or you don't. And you can see on the right-hand side, we have the total of each of those options. Ride the bus, we have 108 students who ride the bus. I don't care how many clubs you're in, I just know 108 of you ride the bus. And 142 of you do not ride the bus. Again, I'm not looking at the second variable. Right now, I'm just looking at the one variable. On top, we have our second variable, which is, hey, how many clubs do you belong to? Now, we organized it in a categorical way. This also could be a quantitative variable, but in this case, it's categorical because you're either in no clubs, you're either in one club, or two or more. So we organized it into 3 different categories. So our one variable is how do you get to school, and our second variable is how many clubs are you in. Again, we could break down how many clubs you're in without even looking at how you get to school. So the member of no clubs, there are 71 students who are members of no clubs. There are 77 students who are members of one club, and so on. And we can see our total, right? We have 250 kids that we surveyed or that we sampled. At any point, feel free to stop me and ask a question. Some of this stuff can be a little bit confusing as we talk and use more academic language around categorical versus quantitative, conditional probabilities, all that stuff. So feel free to shoot a question over on the right-hand side. Also, let me know what book you're using. It's really helpful for me to kind of tailor a lot of these lessons to what book you're using so I can know your scope and sequence. So let's take a look at our first question. What proportion of students that ride the bus are members of 2 or more clubs? So we're looking for what proportion of students that ride the bus. So we do not care about students that don't ride the bus. Right now, we're just looking at the kids who ride the bus. So we know 108 students ride the bus, and we can see that right over there in that total column. Of those 108 kids, how many are members of 2 or more clubs? Well, again, super easy. This is why we like two-way tables. 20 of those 108 kids are members of 2 or more clubs. So our proportion here would be 20 divided by 108. AP exam tip. You do not need to reduce on the AP exam to get full credit. If you put 20 out of 108, you will get full credit on the AP exam. So don't feel like you have to reduce to get full credit on the AP exam. You also don't need to convert it into a decimal or percent if they're not being specific about what they want. So any form will work. Let's try another one. Question 2. What proportion of students that are members of no clubs do not ride the bus? Okay, we're still kind of working with that same idea of focusing on one group of students. What proportion of students that are members of no clubs? So if you're a member of a club, great, but we don't care about you right now. So there are 71 students who are members of no clubs. Of those 71 students, how many do not ride the bus? Again, two-way tables are great for pulling out that information. We can clearly see that 16 of those 71 students do not ride the bus. So again, if we were looking to answer this question on the AP exam, 16 out of 71. And the AP question, the AP test will definitely have a good amount of these questions. Next, what proportion of students that do not ride the school bus are members of at least one club? So again, we're diving into this question. What proportion of students that do not ride the school bus? So we don't care about students that ride the bus. We care about the ones that don't. So that's 140 students total. Out of that 140 students, how many of them are a member of at least one club? This one's tricky. Member of at least one club. So we know it's going to be that 44. But then we also have that 82 that we need to add to it. Because 44 are a member of one club, but the question's asking for at least one club, which is tricky. They're trying to trick you here, right? at least one club. If I am in 2 or more clubs, I am also in at least one. The AP test is going to do that quite a bit when it comes to probability. So when it comes to the probability unit, make sure you're reading the question very, very carefully. How do you get better at it? Well, you just practice. That's usually unit 5. It comes around, kind of depends on your teacher's scope and sequence, but it tends to come around the holidays. So November, December, that's when probability tends to come into play. But you want to be careful when you're reading the question. So the proportion of students that do not ride the bus, again, we're focusing on that second row, do not ride the bus, 142. At least one club is going to be that 44 and 82 added together. So we're going to have, 126 out of 42. All right, here's 3 more practice problems. We have a brand new table. Again, two-way tables are used for categorical data. Categorical data, when you answer the question, you usually give a category that it goes into, like what's your hair color? What's your chance of being rich in this case? Right, so categorical data, if we have 2 of them and we want to look at them together, we use a two-way table. If it's just one categorical variable, we like bar or pie charts. Okay, so this is 2 categorical datas. Right now we're looking at, hey, what are your chances of getting rich? And what is your gender? So we're looking at those 2 different categorical data sets. So first, what proportion of people who identify as males have a good chance at being rich? So I don't care about people who identify as female right now. I'm just focused on people who identify as male. And what's the probability of a good chance? So the total male population here is going to be 2,459. Go ahead and take a look at that at the very, very bottom. See that total? That gives us the total amount of men in this survey. Of those 249 or 2,459 students, how many of them have a good chance? So again, we're excluding the females right now, and we're looking only at the men and the 50-50, or I'm sorry, the good chance of being chosen. So it looks like 758 out of 200 or 2,459 is the proportion of males that have a good chance at being rich. Another AP tip, you do not have to reduce that number in order to get full credit on the exam. So if they're asking for that on the exam, you can just give that number. Don't waste your time reducing it. It's just going to eat into the time. Again, I want to remind you, feel free to ask any questions over on the right-hand side. If this is review, let me know. If this is something you're going over right now, let me know. We're going to have 2 streams going this week, one focused on chapter 1, which tends to be displaying and describing data. And then we're also going to have a designing studies, so experiments and surveys going on tomorrow with Jerry. Let's look at question 2. What proportion of females, or people who identify as female, have a 50-50 chance at being rich? Again, we're excluding the males. We don't care about the males right now. We're just looking at people who identify as female. That's a total of 2,367. Out of those 2,367, how many have a 50-50 shot at being rich? Well, it looks like 696 students. So 696 out of 2,367, that would be your answer here. You can convert that to a decimal or a percentage, but for the AP exam, you don't have to. So why bother? Next, last one. What proportion of young adults have an almost certain chance of being rich? Are male. Read that weird? Let's try that again. What proportion of young adults that have an almost certain chance of being rich are male? So now we're looking at almost certain as our category. So that's what we care about. Everyone else, we don't care about. So that is a 1,083 sample size, right? So we're looking at that bottom row, almost certain, 1,083. Of those 1,083, how many identify as male? Well, that's going to be 597 out of 1,083. So that gives us that percentage. But again, we do not need to reduce or simplify that. All right, so there are some categorical displays that we want to talk about. This is some data on class and how many AP classes you're taking. So the top, we have the categorical variable of what grade level are you in? And on the right, we have how many APs are you taking? 1, 2, 3, and I spelled 2 wrong. 1, 2, 3, or 4, or 5. This is called a segmented bar graph. So a segmented bar graph allows us to look at one categorical variable and see how the distribution plays out in that one categorical variable. So we have the categorical variable of class level. We have sophomore, junior, senior. Of the sophomores, we can now look to see how many students are taking 1, 2, 3, 4, or 5 categorical variables. This was one of the AP questions, I believe it was pretty recent, 2016, I want to say, but I'll double check that. So the way you create a segmented bar graph is you find your percentages, and those come from your table, and you create those percentages in your bar graph. So let's look at sophomore. You can see that no students took 1 AP, which is why when we look at our segmented bar graph, there's no dark blue, because 0% of people who were sophomores took only 1 AP class. 1 took 2. And looking at our total, it looks like it cut off, but 1 plus 4 is 5, plus 2 is 7, plus another 7 is 14. So 1 out of 17 is going to be about, looks like 8%. Or 14, I'm sorry. So that is 8% of sophomores took 2 AP classes. Then we see this little green bar. That's how many students that were sophomores took 3 AP classes. So going back here, it looks like 4 students out of our sophomores took 3 AP classes. Again, we total that up. That's going to be 4 out of 14. And that's going to be around, let's see, 8 to about 35. So that's around 28%. Now notice it ends at 35, 36. That's because we're including this 8% right here. So segmented bar graphs can just kind of stack on each other. And the idea is at the end of it, you have 100% of your data in that subcategory. So this right here accounts for all sophomores in our survey. This right here counts for 100% of our juniors. This right here is 100% of our seniors. It breaks it up by the second categorical variable, which in this case is how many APs are you taking. We like segmented bar graphs because it allows us to compare not only within one categorical variable, like, hey, let's look at just the sophomores, but it also allows us to compare across. So very, very quickly with a segmented bar graph, we can see, hey, there are more juniors taking 3 AP classes than any other grade level. There are more sophomores taking 4 AP classes than any other grade level. So we really, really like using segmented bar graphs to compare categorical distributions. And that always comes from a two-way table. Here's another one from that last data set that we looked at, that last two-way table, which was, hey, how do you get to school? And how many members or how many clubs are you a member of? Right away, your eye should be drawn. Hey, people who don't ride the bus are in 2 or more clubs. People who ride the bus, there are more people that are in no clubs that don't ride the bus, or that ride the bus. And that might tell you something, right? If you're doing kind of an investigation on trying to get more kids into clubs, all right, well, it looks like maybe we have a problem with transportation because students that ride the bus tend not to stay after school to join clubs. But if you don't ride the bus, if you find some other way of transportation, you tend to be more involved in clubs. So if you're a school trying to get students involved in clubs to maybe increase their ability to apply for colleges, you might want to look at this type of data and make decisions based off this data. The reason why I love this class is if you're a smart, really just a smart person in the world, and you're doing your job well, you're probably looking at data to inform your decisions. If you're just kind of making decisions based off your gut feeling, not as effective as if you're looking at data. So this right here is a segmented bar graph. Once again, we can see that about 50, maybe 52% of students ride the bus are members of no clubs. And again, if we look at our two-way table, we got that percentage from here, right? We just didn't simplify it or didn't convert it. We just wrote it as, let's say, I think we said 82 out of 142. So we got that percentage, and then we came over to our segmented bar graph and put that in there. Then we looked at, okay, people who ride the school bus, how many are member of one club? So people who ride the school bus, member of one club. We went over to ride the school bus, 108. Looked at member of one club, that 33. Took 33, divided it by 108. Came back here and put that percentage. We stacked it on the first one. And the idea is after we stack all the different categorical or subcategories in the categorical variable, we have 100%. All right, well, that was a quick session on how to analyze categorical data. I want to quickly review. We have categorical versus quantitative. We use bar and pie charts to display categorical data if it's one category. If it's two, we use two-way tables and segmented bar graphs. Please follow us on Think5able, Twitter, Instagram, YouTube. I personally do not have a handle right now. I'm looking to maybe create my own Instagram handle, but for right now, follow 5able. That's your best way to connect with me. I'll stick around to answer any questions, as well as hear from you all as far as where you are in your scope and sequence. I would love to hear from Ari and Pearl if you have just a quick, hey, here's what we're covering. If you have a dying question that you want answered right now that I didn't cover, feel free to pop it into the chat and I will answer that question. If not, tune in tomorrow where Jerry is going live with sampling methods and biases, sources of biases. It'll be a great one, and I'll be back. I'm shooting for Thursday, but it might be next week as well. Thanks, and have a good evening.